Okay, we're going to continue on this review. And we're going to start with problem 11. As Ms. Blumberg said, we're not doing every problem in the review sheet, but we're doing the problems that seem to give the students the most trouble. So let's look at problem number 11. Problem number 11 says, solve the formula for the variable indicated in A. Okay? So let's look at in A and B. So let's look at problem B. This is a formula. It says A equal B minus BRS. And this is called a literal equation because it only has letters in it. Okay? And when we work a problem with letters, it seems to be a whole lot more difficult than when we have numbers. So basically, this is a problem something like this. If I have 4 is equal to 1 minus 2s. If I had a problem like that, and I'm solving for the variable s, it would be fairly easy. What I could do is first subtract 1 from both sides of my equation, and I get 3 is equal to a negative 2s. So what I'm trying to do is get my variable s by itself. Well, now when I have an s, I have a negative 2s. Negative 2s means negative 2 times s. And when you're solving equations, you want to do the inverse operation. So the opposite of dividing or multiplying by a negative 2 would be dividing by a negative 2. And if I divide both sides of my equation by a negative 2, I would get s is equal to 3 over a negative 2. And I don't like to leave a negative in the denominator, so I'll write my fraction as negative 3 over 2. This is a simple version of this more difficult problem. So let's look at the difficult problem where it says solve for s. And I have 2 steps, very similar to the 2 steps I had to do here. The first thing I want to do is eliminate this b from the right-hand side of my equation. So what I can do is subtract b from both sides of my equation. So I'm going to go minus b, just like I did with this number 1. A minus b, though, can't simplify together. So I'm just going to write it as a subtract b equal. And b subtract b is 0, so they add out. And I have a minus brs. Okay. Very similar to what I had here. Now again, we have to go back and look at the problem, and it says solve the equation for the variable s. And here is my variable s. Well, when I have a negative BRS, when there is no symbol in between variables, which are your letters, that means I'm multiplying. So this says I'm multiplying a negative b times an r times an s. And the opposite of multiplying, the inverse operation, is dividing. So I'm going to divide both sides of my equation by what I want to eliminate, which in this case is a negative b and an r, and that will leave me with an s. So I'm going to divide both sides of my equation by a negative br. Well, on the right side of my equation, the b's and the r's reduce to 1, and 1 times s is just s. And on the left side of my equation, I have a subtract b over minus br. Now that is a correct answer, but it's not an answer the way we like to see it. What's wrong with this answer, or not wrong, but what I don't like to see, is a negative in the denominator. So whenever I have a negative in the denominator, I like to eliminate it from the denominator because it usually makes a problem more difficult. So just like I had in this case where I had 3 over a negative 2, I know that when I divide a positive by a negative, I get a negative. So another way of writing that would be negative 3 over 2, or a negative 3 over 2. I can take this negative in the denominator and either bring it in front of the entire fraction or in the numerator. So when I have this negative in the denominator, I do not want to leave it there, so I have a choice. I can bring it in front of the entire fraction or bring it up to the numerator. And in this case, I think it would be a little easier just to write it in front of my fraction, and I will get negative this fraction, a minus b over br, is equal to s. Now you're working on your final exam with a multiple choice test. If you weren't using multiple choice, that would be a perfectly good answer. This is a good answer, usually not in the form that we like. But if you don't find this answer on your final exam as a multiple choice, what you could do is multiply through by that negative sign. And if I do, I get negative a plus b over br is equal to s. And that in turn is just b minus a over br equal s. So you're going to probably see this form of an answer or this form of an answer, and they are equivalent. They are exactly the same, just in a different form. Okay? These are literal equations. They're a little bit more difficult. If you have trouble solving literal equations, go back and use an easier form and write it with numbers. Okay? Let's go to the second part of the problem. And the second part of the problem says, I have an equation, and this is part 11c. And this particular equation, 11c, said, I have the equation y is equal to mx plus b, and it says for b. If I were solving this equation for b, I would like to get b by itself. Now the actual instructions for this problem said, if I know the values of my variables y, m, and x, what is the value of b? So we can substitute in these values to find the value of b. They're trying to solve the equation for the value of b. Okay. Now you should be familiar with this formula because we're going to be working with it today, and this is the equation, one of the many equations for the equation of a line. This is called the slope-intercept form of a line. Y equals m, and m stands for the slope, times x plus b, and b stands for the y-intercept. You all picked up a formula sheet, and that formula sheet has that formula in it, and you're going to be working with it a lot. Okay? Now, in this particular problem, what we're doing is not solving for the letter b, but finding the value of the letter b if we know the value of y, m, and x. So what we're going to do is just substitute these three numbers for our variables and solve for the missing one. So there are 4 variables. If I know any of the 3, I can find for the 4th. So instead of the y, I'm going to write the value of y, which is 6. The value of my slope, which is m, is a negative 2. And it says mx. When there is no symbol between two variables, you need to know that it means multiply. So mx means m times x. M is a negative 2. X is a 1, so I'm going to multiply it by 1 plus b. So in this particular problem, again, they're saying solve for the value of b numerically. Now that I've substituted in, I only have one variable, I can do that. I'm going to do my multiplication first. So I have 6 is equal to negative 2 times 1 is negative 2 plus b. So now I have a simplified form of the equation. And the simplified form of the equation to solve for the variable b is to do the opposite of subtracting 1, or the inverse operation of subtract 2 is add 2 to both sides of my equation. And 6 plus 2 is 8. And 2 minus 2 is 0. So 0 plus b is b. So I have 8 is equal to b. And that's what I was looking for, the value of the number or the variable b. Some people, 8 is equal to b, or I could write b is equal to 8. And that's one of our math properties that allows us to do that. Okay? So in problem 11b, we were solving literally for an equation, and in problem C, we were finding the numerical value in an equation. Any questions? Okay? Now we get to these problems that everybody likes, and these are the word problems. And this is problem number 12, 12a. Okay? When I'm working up in the math lab, that's usually when I have the students come to me most quickly, is I've got a word problem, I don't know what to do. So we're going to work on this and try to simplify it. Okay? The one thing that you're going to have to remember whenever you work any kind of a word problem, no matter what course you're in or whatever it is, that you cannot just look at it and work it. There are several steps into working a word problem successfully. You're going to read the problem first to get an idea of what they're looking for. And then you're going to have to read it 2 or 3 or 4 times until you can really get the gist of what the problem is saying. So in problem number 12a, it says the width of a rectangle is 7 less than its length, and the perimeter is 30 centimeters. What is the length? All those words run into each other. So I know I'm working with a rectangle. In the first read, that's what I saw, a rectangle. So the first thing I want to do is draw a rectangle to give me an idea of what's going on. So I'm going to draw a rectangle. And a rectangle has right angles, and opposite sides have the same value. They say opposite sides are congruent, or the lengths of the opposite sides are the same. So I know I have a rectangle, and I know that the perimeter of this rectangle is 30 centimeters. On my first read, that's all I got. Okay? If you have a geometric figure, the first thing you want to do is draw the picture. Okay? And again, opposite sides have the same length. That part I know. Now I have to get to the hard part. The hard part says the width of the rectangle is 7 centimeters less than the length. Now whenever you're doing a word problem, one of the easiest things to do is I'm dealing with two different things. I'm dealing with the word width, and I'm dealing with the word length. And I have to let something represent both the width and the length. And it's usually easier. Now notice I said usually because nothing is absolute here. But it's usually easier to let my variable, which is a letter, stand for what something is being compared to. So I'm saying, is the width being compared to the length, or the length being compared to the width? Whatever something is being compared to is usually what I want to make my variable represent. So the width is less than the length. So I'm comparing the width to the length. So I'm going to make the length my variable. I can call it x, I can call it a, I can call it l, I can call it anything. But I let x be worth the length because I'm comparing the width to the length. Okay? The width of a rectangle, so now we're talking about the width, is 7 centimeters less than the length. Well, the length is x, and the width is 7 less than that. So I'm going to write for the width x minus 7, because it is 7 less. And that usually makes a problem easier to see. Again, width is being compared to length, so I let x equal to the length. And then it says the width is 7 less than the length, x minus 7. Now I've left the unit of measurement centimeters off, and I will pick it up at the very end. Now here is the key to making this problem easier. I call this my key. This is the key to making it easier. X minus 7 represents the width, and x is equal to the length. So that you don't make any careless mistakes, I put those values onto my drawing. Now the length is usually the longer side. So this is x, and since the opposite sides have the same value, this is x minus 7 and x minus 7. Right? So I put these values from my key onto my drawing. And now we have to remember what the word perimeter means. The perimeter says what is on the outside. If I were to walk around the figure, how long would I have to walk? If this were a field, how long is it around the field? Now the easy way, without memorizing a formula, says I start and I add up the lengths of all four sides. X minus 7 plus x minus 7 plus x is going to give me the distance all the way around. And according to the problem, that distance is 30. So I'm going to write a simple equation just using logic without any of the formulas that you have on your formula sheet. And then I will go over the formulas on the formula sheet to show how you could use it that way. So if I add up all four sides of my rectangle, I have x minus 7 plus x minus 7 plus x, and I know that whole length is worth 30. Now I put these in parentheses so it would be easy for you to see. This is one length, the second length, the third length, and the fourth length. As long as I have plus signs, I really didn't need the parentheses, but I wanted to show you that they were individual sides. So now I'm going to combine like terms, which is the words that we usually use in algebra, which means anything that is alike I'm going to add or subtract. So I have x's. I have 1, 2, 3, 4 x's. And I get 4x. And this says I have a minus 7 and a minus 7. Minus 7 plus negative 7 is negative 14. And that's equal to 30. And so I've taken a whole series of words and translated them into math symbols. And now I have an equation that I need to solve. And this equation says 4x minus 14 is equal to 30. Well, in my equation, I want to do the opposite of subtracting 14. I always work the opposite of adding and subtracting first, and the inverse operation of subtract 14 is add 14 to both sides. Negative 14 plus 14 is 0, so I get 4x is equal to 44. And if you're lucky, because you are not permitted to use a calculator on your final exam, the numbers will be fairly easy to work. So I now have 4x is equal to 44. Let's divide both sides of our equation by 4, because that's the opposite or the inverse operation of multiplying by 4. 4 over 4 is 1. 1x is x. And 44 divided by 4 is 11. Okay, that's a fairly easy division problem. Now, I'm not finished with the problem. I've solved an equation. I've solved an equation for x. So now I have to go back to the problem and say, what does x represent? X represents the length of the rectangle. So I'm going to write that the length is equal to 11, and the width in this problem we know is x minus 7, and x is 11, so 11 minus 7 is 4. So the width is equal to 4. Now I'm still not finished, because now I have to go back and remember, what did the problem ask me? So I'm going to go back to the original problem, and the original problem says, what is the length? So I go back here, and I know that the length is 11. Now, do not be surprised if on your final exam they say, what is the sum of the length and the width? Okay? They might not just ask you what is the length, which we got as 11. We got the length was 11, the width was 7. But what if they said, what is the sum of the length and the width? If I want to know what the sum of the length and the width is. Sum means it's the answer to an addition problem. So what's the length? 11. What's the width? 4. So 11 minus 4, and that would be 7, if they ask that question. So you have to go back and always read the problem and answer what they ask, not what you want them to have asked. Okay? Oh, thank you very much. So let's change that to a 15. Okay? Right. There goes my 100% on my final exam. Okay? So the sum means the answer to an addition problem, which is what I said, but not what I wrote. Okay? So sum is 11 plus 4, which is 15. Okay? So if they ask what's the length, the answer would be 11. If they ask what's the width, the answer is 4. If they ask what's the sum, the answer would be 15. Okay? And you could work the problem, but if you don't answer what they ask, you're in trouble. Okay? Thank you very much. Okay? Any questions? Let's go to the next word problem. The next word problem says, twice a number decreased by 1 is equal to 3 times the number increased by 3. What is the number? This is 12b. 12b. I've read through that, and all I can see is a whole bunch of words. That's your first read. So all I'm getting out of that first read is the last part. What is the number? I know I'm looking for a number. Okay? And the key to the problem is writing down what you're looking for, what you're given. So the key in this problem is I'm going to let x is equal to the number that I'm looking for. The number. What is the number? That's all I got out of my first reading. What am I looking for? X. So now I have to go back and reread the problem and see if I can make some sense out of it. First read is just giving you an idea of what the problem is stating. So it says twice a number. So if I say the number 5, twice 5 is how much? 10, right? Twice 5 is 10. Oops, twice 5 is 10. If I give you the number 7, what's twice 7? 14, what'd you do? 2 times 7, or 14. So twice something means to multiply by 2. Okay? Do not get twice confused with the word squared. Squared says multiply it by itself. Twice is the same thing as double, and twice and double means multiply by 2. So twice a number. What's my number? No, what did I let? X. X. And I want twice that. So what's twice x? 2x. Decrease. What does decrease mean? Subtract. Subtract. How much am I decreasing it? By 1. Is. This word is always equal to. Is present tense. Anytime you have the word is, that's a math verb. And a math verb that has the word is an equal to sign. If you're doing past tense, was, it's still equal to. Will be is future tense, it's equal to. Anytime you see a form of the word is, you know it's an equal to sign. Present, past, future, whatever. And that's equal to 3 times the number. My number is x, so how do I write 3 times the number? 3x increased plus 3. So you've taken a whole bunch of words and translated them literally. But the key to the problem is writing the key. What are you looking for? If you write this down, then the second line, the equation, will generally be easier to see. And now I'm ready to solve this equation. Okay? There are no like terms on either side of the equal to sign that I can combine. So what I want to do is get variables on one side, numbers on the other. And it doesn't matter which side I get my variables on. A lot of teachers teach different ways. A lot of teachers say, oh, get your variables on the side that you have the most, which is on the right side in this case. And a lot of teachers always put their variables on the left side. It doesn't matter. Okay? Absolutely does not. If you, depending on the side you choose, you'll be working with a negative number or not a negative number, but in the very end it works the same. In this case, just for convenience, I'm going to subtract 2x from both sides of my equation. And if I'm subtracting 2x from both sides of my equation, what I've decided to do is get my x's on the right-hand side. 2x subtract 2x is 0, so I get a negative 1 equal. And the reason I chose the right side is because the arithmetic is a little easier. 3x minus 2x is just x, or 1x, plus 3. So now I have a simplified form of the equation which says negative 1 is equal to x plus 3. I'm still solving for my variable x, my letter x. So what I have to do is get x, but isolate the x. So I'm going to do the inverse operation of adding 3, which will be subtracting 3. And 3 minus 3 is 0, so on the right-hand side I get an x. And on the left-hand side I have a negative 3 and a negative 1 that I'm adding together. And this, if nothing else, is what's going to give some of you trouble, is that you have difficulties with the signed numbers. I have a negative 1, and then I have another negative 3, so altogether I have a negative 4. So negative 4 is equal to x. And if you had solved and put your variables on the left side, you would have gotten x is equal to a negative 4. Same problem, just using properties of equations to rewrite them. Now, again, I have to go back and see, have I answered the question? And the question says, what is the number? So x is equal to the number. And as Ms. Blumberg said, what you really want to do is you want to check, is my answer correct? So it says, what is the number? And I say that number is negative 4. So let's see if it works. Twice a number. 2 times a negative 4. Because that's what we said our number was. Decrease by 1. Subtract 1 is supposed to give me the same value as 3 times that number increased by 3. Okay? So let's see, did I get the right answer? Are these two expressions equal? Well, 2 times a negative 4, positive times a negative is a negative, so that's a negative 8. Subtract 1. And again, a negative 8 and a negative 1 gives me a negative 9. Okay? 3 times a negative 4, positive times negative is negative. I get a negative 12 plus 3. When I'm adding a positive and a negative, I subtract the absolute values of those numbers and I take the sign of the largest absolute value. So negative 12 plus 3, I subtract, I get a 9. Since my 12 has a negative, I get a negative 9. So I know I've worked the problem. I go back and check. Questions about this? Okay, let's just move right on. is percent. Okay? Out of your course, the Math 0300 course, the percent problems, no matter what you do the rest of your life, are the most beneficial. They're the problems that you use most often. And there are three basic types of percent problems. And we have three examples of the three different types of percent problems. Now, the only thing difficult about percent is there are about 10 different ways of teaching percent. And every time you learn percent, probably one of your instructors teaches it to you differently. So I'm going to show you two basic ways because I am sure that half the class were taught one way and the other half were taught the other. And I think that you should work these the way you're most comfortable. One is not better than the other. They're just different ways of working the same problem. That's what makes math difficult. There's more than one way of working a problem. Okay? So 13b says 15% of what number is 48? And again, you're not allowed to use a calculator on this test, so you've got to be able to figure out a problem. Here is the hint. What does, when you see the word is, what symbol do you always write? Equal. And this is the tricky part. When you see the word of, that really means multiply. And most people don't get that. Of means multiply. All right? So the first thing we're going to do when we work this problem is to translate it literally, word for word. I'm going to read the problem first, just like I've done on all word problems, and then I'm going to go back and translate. 15% of what number is 48? So the problem says what number, and what are we going to let represent that number? X. That's my key, and I'm writing that X is my key. You could have used A, you could have used Y, you could have used Z. I'm so used to writing X's that I do it all the time. I'm in a rut. I eat the same thing for breakfast every day. Okay. So it says 15%. Now you can't use a percent symbol in mathematics to do actual arithmetic, so you have to change the percent to a decimal. These two zeros really mean divide by 100. So that means you take the decimal point at the number 15 and you're dividing it by 100, which means you're moving that decimal point 2 places to the left. So 15% is really 0.15. Okay? Of, what did I say of means? Multiply. And what number is X? So I'm going to go times X is equal to 48. And in fact, if you just translate these problems word for word, then what happens is that they become the easiest word problems you're ever going to have. So I want to solve this equation for X. What do I have to do to both sides of my equation? Divide by 0.15 or 1500ths. And my 1500ths divided by 1500ths, or 0.15 divided by 0.15, is the number 1. Any number divided by itself is 1 except 0. And I get X is equal to 48 divided by 0.15. Okay? That's the easy part. The hard part on this problem is, since you are not allowed to use a calculator, is how do I divide? Now there are a couple of things, and I'm just going to review the division. The way I divide is probably different than the way you divide it, because when I grew up they didn't have calculators and we were taught all kinds of shortcuts. But I'm going to divide 1500ths into 48. And you're not allowed to divide by a decimal at all. So I'm going to move that decimal point 2 places in my divisor, and that means I have to move it 2 places in my dividend, what I'm dividing into. But I have to move the decimal point 2 places, but it's hidden. It's not there. It's understood to be there, and I got to find it. So when the decimal point isn't written, it's always after the number. And I've moved my decimal point in the 0.15 or the 1500ths 2 places, so I now have to move it 2 places. And I bring it straight up. And now I say 15 divides into 4800 or 4,800. Well, the first number that 15 can divide into is 48. And I can count by 15s, 15, 30, 45. So it goes 3 times. Okay, I'm thinking 15, 30, 45, 60. I'm dividing like that. 3 times 15. 3 times 5 is 15. 3 times 1 is 3 plus 1. I knew it was 45. I subtract, and I get a 3. And I bring down one number at a time. 15 into 30 is 2. 2 times 15 is 30. I now have to keep on bringing a number down till I get to my decimal point, which is 0. 15 divides into 0 times. So my answer is 320. The hard part of this problem wasn't the algebra. The hard part was the basic arithmetic. I think this is stuff that we're so used to a calculator that we no longer know how to do by hand. Okay? Now let me show you my shortcut, just because I feel like I need to show you my shortcut. If I have 48 divided by 1/5, okay? I need to move my decimal point right here 2 places. If I move it here, I move it here 2 places. So now I have 4800 over 15, which is the same thing that I have over here. And I reduce. I know that 5 goes into 15 3 times. And I know 5 will go into my numerator because it ends in a 0. Any number that ends in a 0 or a 5 can be reduced by 5. 5 into 48 is 9, with 3 left over. And 5, oops. Oh, let's see. Let's go back. Let's try 4800 again by 15. And I'm dividing by 5. It's going to go 3 times. 9. 5 into 48 is 45 with 3 left over. 5 into 30 is 60. And 5 into 0 is 0. So I have 960 divided by 3. And this will divide by 3. 3 into 3 is 1. 3 into 9 is 3. 3 into 6 is 2. And 3 into 0 is 0. So I still come up with the 320 a different way. So I would say that most of you would do the long division method, but you can do it the fraction method too. All right, let's go to the next problem, which is problem 13C. 20 is what percent of 80? Okay, I've read it through the first time. I now want to get my key. What percent? That's my x. Okay? 20. What am I going to write for the word is? Equal. What percent? What am I writing for that? X of multiply 80. Translation, word for word. Okay. I want to get the x by itself. It says x times 80. What's the opposite or the inverse operation of multiplying by 80? Dividing by 80. So I'm going to divide both sides of my equation by 80. and I'll get x is equal to 20 over 80. Now this is where you should really reduce, not do long division here. Okay, the 2 zeros reduce, that's dividing by 10. And I now have 2 over 8. And 2 and 8 both reduce by 2, and I get 1/4. Now let's go back and see what I'm looking for. I'm looking for the percent. And 1/4 is an answer, but it's not in percent. Okay? So I have to change this number into percent. So I'm going to do that 4 divided into 1. Okay? Because I want to know the decimal. Most of you know the decimal for 1/4. A fourth of a dollar is 25 cents or 0.25. So I in my head know that x is 0.25. But if you don't know it, you're going to do the division. Okay? So I'm going to divide 4 into 1, and it doesn't hurt to review how to divide. This is a whole number, the 4, but I have to divide it into 1. I have to put a decimal and bring my decimal straight up and add a 0. 4 divides into 10 2 times. 2 times 4 is 8. When I subtract, I get 2. I still have to keep going until it either repeats or terminates. I have to bring down my 0. 4 into 20 is 5. 5 times 4 is 20. So I get my 0.25 if I didn't recognize the fraction of 1/4 is 0.25. I'm sure because of money, almost everybody realizes that. But let's go back. It says what percent? I still have a decimal. I don't have a percent. To get a percent, all I need to do is move my decimal 2 places to the right. 1, 2, and I get 25% is my answer to this problem. Okay? Question. Literal translations on this. Okay? And let's get to the last problem. Okay? And I have not learned 3 different methods. All I have learned to do is translate word for word. The last problem in number 13D says, what number is 30% of 150? I'm looking for what number. That's my key. That's my X. So I've written my key. X stands for the number. Now it says what number. So what am I going to translate that what number? What am I going to write? X is equal 30%. I can't use percent. I've got to change it to a decimal. This percent sign says divide by 100, which means I move my decimal point 2 places to the left. 1, 2, and that's 0.30. Some of you can write it as just 0.3. Of, what does of mean? Multiply 150. That's all I'm doing. So the algebra part was simple. The part we have to do now is multiply 0.3 or 0.30 and 150. So I'm going to write 150, and a 0 at the very end doesn't have any place value, so I'm just going to go times 0.3. So 3 times 0 is 0. 3 times 5 is 15. Carry your 1. 3 times 1 is 3, plus 1 is 4. And when you're multiplying, you have to count the number of decimal places after the decimal point. There is one, excuse me, 1 decimal place. So my answer is 45.0, or just 45. So I'm saying 45 is 30% of 150. So if something cost $150 and I got a 30% sale, how much am I getting off? $45. That's what it means. Okay? question. Okay? Simple translation. This is not the only way to work percent problems, but it goes along with word problems. Okay? All right, let's move on. We're on problem number 14. Problem 14, you have to read the instructions. The instructions say, solve the following inequalities, graph the solution set on a number line, and indicate the solution set in interval notation. Okay? This has 3 instructions to this one problem. So there are 3 things that you need to do to this problem. Chances are, when you take a test over this, they'll ask you one of the 3, not all 3. But by working all 3, you'll know how to do them so that you know what they're asking. When I say 3 parts to this problem, the first part says solve it. The second part says graph the solution set, which means the set of answers. And the third part says write it in interval notation. So there are 3 parts to this problem. Okay? Now when we're dealing with inequalities, the first inequality says 3x plus 5 is less than or equal to 8. What makes an inequality different than an equation is that you have either a less than symbol or a greater than symbol. That makes it an inequality. Okay? And the rules for inequalities are exactly the same for equations except for one difference. And the difference that will make the solving inequalities easier for you is that if ever you multiply an inequality or divide an inequality by a negative sign, the direction reverses. So here's an example of what I'm talking about. I have a very simple version of a problem. Negative 2x is greater than 14. Okay? I want to know the values of x that make this a true statement. That's what solving an inequality means. So I'm going to divide both sides of my inequality by a negative 2, just like I would do in an equation. The negative 2 over negative 2 reduces to 1, and I have 1 times x, or x. The difference is that whenever you multiply or divide an inequality by a negative sign, the direction of the inequality reverses. This is greater than, the reversal of greater than is less than, and 14 divided by a negative 2 is a negative 7. So that's the difference with working with inequalities from equations. Okay? All right. I don't have an equal to sign, so this says, and let's look a picture of the graph. Here is the number negative 7. It says the solutions to this problem are all values of x that are less than a negative 7. Okay? One of the is negative 7 an answer to this problem? Is negative 7 less than negative 7? Is negative 7 less than negative 7? No. Is 8 less than negative 7? Is 8 a number smaller than negative 7? No. Is 0 less than negative 7? No. Is negative 10 less than negative 7? Yes. So 10 would be here, negative 10. What about negative 20? Negative 8.5? Yes. Well, there's not a set number of answers. So when we say there are multiple answers, we say the answers are infinite. And they are anything smaller than a negative 7, so I shade on my number line. And I need to make an indication around the negative 7 to show whether negative 7 is included or whether negative 7 is not included. Well, negative 7 is not less than negative 7, so I use a parentheses. When you don't have an equal to sign, you use a parentheses. So this indicates any value smaller than a negative 7 would be an answer to the problem. And we're saying that's infinite solutions. Any number to the left of my negative 7. And now if I wanted to write that in interval notation, so this is the solution to the problem. This is the graph of the problem. And the interval notation says write all answers out in an interval. Well, my answers go to negative infinity. A negative 3 million is less than a negative 7. Okay? A negative 5,842,932,000 is less than a negative 7. So we write a parentheses, negative infinity, up to negative 7, and since I'm not including negative 7, I write a parentheses. That indicates in interval notation the complete solution set, always with a parentheses because it never stops. You only use a bracket if you're stopping at a specific number. Okay? So now let's work part A. Okay? 3x plus 5 is less than or equal to 8. And it helps if the problem is on the graph. Okay? Three x plus 5 is less than or equal to 8. All right, I'm going to work this very similar to an equation. I want to get my variable by itself. In working inequalities, unlike an equation, it will usually make your answers easier to understand if you always put your variables on the left side. I always want to keep my variables on the left side. You'll have less mistakes at the very end of your problem. Okay, so I want to get x by itself. I'm going to, what am I going to do? Subtract 5 from both sides of my equation, or inequality. It's an equation because I have an equal sign, and it's an inequality because I have a less than symbol. 5 subtract 5 is 0, so I get 3x is less than or equal to 8. Now remember, I started off with a less than or equal to symbol here, and I still have a less than or equal to symbol here, even though I'm subtracting a negative. The only time the direction changes is when you multiply or divide. I want to get x by itself. I divide both sides of my inequality by 3. That's a positive number. It doesn't reverse the direction of my inequality. My handwriting is so bad that you didn't recognize the difference between my 3 and my 5. Right? So my 8 minus 5 is 3. Divide both sides by 3. And I've got x is less than or equal to 3 divided by 3 is 1. So this is my solution by solving the inequality. Any value that's less than or equal to 1. Okay? Oh, my 100 before was a 97, and now it's a 95. Okay, I made 2 mistakes. Okay. All right, so let's go on. I want to graph it. Here is the number 1. My arrow points to the left. I'm looking for the smaller than values. So there's more than one answer. 0 is less than 1. 5 is less, no, 5's not less than 1. Negative 5 is less than 1. Negative 1 million is less than 1. So it's all these numbers on this side of the 1. So I'm going to shade to the left of 1. And now I have to decide what to do about 1. Is 1 less than or equal to 1? Yes, because 1 equals 1. So to show that I want that number included, I'm going to put in a bracket. Whenever there's an equal to sign, you put in a bracket. So now I've got the second part of what they asked us to do, which is the graph. And then the third part that they're asking us to do is write this in interval notation. And so I'm going from a negative infinity up to a negative 1, but not only up to a negative 1, but including a negative 1, so I put a bracket here. And so that is my answer in interval notation. Okay? So I've got the solution, the graph, and the interval solution. The solution written in interval form, the solution written in graphical form, the solution written in set form. Okay? Let's go on to the next question. The next question is fairly easy, but it's illustrating what I showed you before. Negative 5x is less than negative 10. This is 14c. Okay, I want to leave my variable on the left side, and I want to get negative 5x less than 10. I want to solve for the variable x, so I'm going to divide both sides of my equation by negative 5. Negative 5x divided by negative 5 less than negative 10 divided by negative 5. Negative 5 divided by negative 5 is 1. 1 times x is x. But when I divide by a negative, I reverse the inequality, so less than becomes greater than. And a negative divided by a negative is positive, so negative 10 divided by negative 5 is 2. Okay? So that's my solution. Let's graph it, because that was another part of the problem. Here is 2. How I want to make sure I know where to graph, my arrow tells me which way I graph, but I say, okay, is 0 greater than 2? No. Is 5 greater than 2? Yes. Is 10 greater than 2? Yes. So it's the numbers on the right-hand side. So it's everything to the right of 2, and now I need to decide, is 2 included in the problem? Is 2 greater than 2? No. So I use a parentheses. And so I have infinite solutions. They start with any number larger than 2 and go to positive infinity. So this is the interval notation, starts at 2, goes to positive infinity, and I have parentheses at the 2 and parentheses at the infinity, because there's no end to infinity. There's no stopping point. Okay? Question? Okay, let's go to the last one on the inequalities, number D. This is 14D. 2/5 x is greater than or equal to 2, right? When I work this problem, there are two ways. I can do this problem in 2 steps, or I can do it in 1 step. Generally, when you have problems, the more steps you do, the less mistakes you make. And this is a problem that has fractions in it. When I have fractions, the easiest thing to do is to find your common denominator and multiply both sides of your equation or both sides of your inequality by your common denominator. In this case, it's 5. So I want to multiply both sides of my inequality by 5, just like Miss Blumberg showed. And that looks like a 3, but it's really a 5, right? My 3's and my 5's. It's kind of mess up. Well, 5 is 5 over 1, and those 5's reduce, and all I have left is 2x is greater than or equal to 10, because I multiplied by 5. Divide both sides of my inequality by 2, and I get x is greater than or equal to 5. That is my solution. And now I'm going to do my graph. I find the number 5. And it says I want anything larger than 5, greater than 5. Numbers that are greater than 5, bigger numbers are to the right. The arrow is pointing to the right. I'm going to go to the right. So I'm going to shade everything to the right. Notice my arrow on my number line. This arrow is pointing the same way I'm shading. If I had a less than, I would be pointing to that arrow. That tells you how you shade. That arrow is pointing in that direction the same way I have this. Makes it an easy way to remember. Okay? And I need to know, what am I going to do about 5? Is 5 included or is 5 not included? It's included. 5 is not greater than 5, but 5 is equal to 5. And when the number is included, I use a bracket. Okay? So I've got the solution, I've got the graph, and the third part said write it in interval notation. The very first number I have is a 5. I go to positive infinity, and whenever you're dealing with infinity, again it's a parentheses because there's no end to infinity. But my interval, there is an end. It stops absolutely at a 5. That's why I have a bracket. Okay? Question? And again, let me just state this once more, because a lot of people have trouble where you're graphing. If I have x is less than 2 on a number line, here's the number 2. I'm matching this arrow with this arrow. And that means I'm graphing this way. And this will be a parentheses. So the direction of your arrow is the same as your direction of your inequality. A lot of people have trouble with that. Okay? Okay, let's go to problem 15a. Okay. 15a. It says, read the following graphs and answer the question. Okay? We've got 2 graphs. We're only doing a few of these and a few of the questions. I've got a graph, and I need to understand the graph before I actually can answer a question. So I want to see what information is given here. A graph always has 3 things to it. It has a title. This title is really important. This graph is a graph of the number of tickets sold each week. Okay? I don't know what the tickets were for, but each week this is a graph of the number of tickets. Then I have 2 axes. I've got a horizontal axis and a vertical axis. So I have 2 axes. And the horizontal axis is labeled as week, which week, and the vertical axis says the number of tickets sold. So if I'm talking about week 2, I look at week 2, and then along the vertical, I will be able to read how many tickets were sold. Okay? So the first part of this problem says, during which week were the greatest number of tickets sold? This is the number of tickets sold. I look to see which one of these bars on this bar graph, and that's what this is a bar graph, which one of the bars has the most number of tickets sold? Well, it's obviously up here. It didn't ask me how many tickets were. It asked me which week. So if you were looking at a multiple choice test, they might have that answer as like 68. And that wouldn't be the correct answer because that would be the answer to the number of tickets. But this says which week. So my 68 is in week 4. So the answer to this question is just week 4. If the question says what was the most number of tickets that were sold, well then I'd have to go across and read on this axis. And you should also see what the scale is. The scale is counting by 5s. 5, 10, 15, 20. So if I wanted to know the number of tickets, it's between 55 and 60, and my best guess would be about a 58 or a 59. Okay? But the question said the week, so I read across the bottom. If the question said tickets, I would read across the vertical. So let's look at the second graph. Okay. And in the second graph, and I need to get this all on the screen for you. Okay, I'm going to look at the graph first. Every graph should have labeled a title and the two axes. Big D sales from 2006 to 2007. Big D, okay? And across the bottom, it says months. So I have month 1, month 2, month 3. I don't know if month 1 is January. It's just a different month in order. This is a line graph. This is called a line graph. And across the side, it says sales, but the important thing says thousands of dollars. So if I have this number right here, which is 48, what was the sales? It's not 48, but it's 48 thousands of dollars. Okay? So you have to read this number along with the vertical axis. And I have the year 2005, and I have the year 2007. So in this particular graph, there were more sales all the time in every single month. And I'm assuming if it goes from 1 to 12, it's from January to December. But that's just my assumption. 2007 was a whole lot better than 2006, okay, according to this graph. But the question, you have to answer the question, when was the first time in 2006 that sales reached above $48,000? And this should be $48,000. They don't need the $1,000 symbol because it's listed here, but it should have 48,000. Okay, there are a couple of things that you need to look at. It says 2006. So I have two choices. So my choices are going to be the line graph that's on the bottom. Okay. I'm looking at 48,000, but here's the key. Above 48,000. So here is 48,000 right there. So it says the first time, which means the first month, that my sales were above 48,000. So let's look at month 1. In month 1, what were the sales? 48,000. Is that above 48,000? No. In month 2, were the sales above 48,000? Yes, and that's the very first time. So the answer to this problem would be month 2. Okay? If the question said, what is the first month that the sales were below 48,000? Then the answer, of course, would be month 3. Okay? So the key here is the word above, and you have to make sure you're on the right line graph. And again, read the labels. That's going to help you out. Okay? Let's go to question number 16. In question number 16, first thing, of course, you're going to do is read the the instructions. In part A, determine the coordinates of the ordered pair on the graph. So let's look here. Graphs, again, should be always labeled. Okay? This is called a rectangular coordinate graph or Cartesian plane. Okay? My labels are X and Y. Graphs should always be labeled, and the scale should always be labeled. Now, not every division has to be labeled, but enough so that you know what every division is worth. So I'm looking at point A. Point A is right here. And remember that your points are always going alphabetically X, Y. So I'm reading across my x-axis to get to point A, and that number is 4. And I go up and I read across, so that coordinate is 4, 3. Point B, I'm starting at 0, 0, and I'm going across till I get to point B, and that coordinate on the x is -4. And I go up and I read across, and that is 6. -4, 6. Okay. I'm going to put in a point C. Let's say I put in a point C right there. C. Okay? It's still x, y. So if I'm here, have I moved at all on the x? No. So my x coordinate is 0, and my y coordinate would be 7. When they're on the axes, they're usually harder for some reason to get the zeros in the right spot. Okay? Part B says, I've given you the point, you do the graph. So we're going to do that. Okay. Point A is -1, -2. If you have trouble remembering, just always go x comma y so you know which one is which. It's always alphabetical. So it says for point A, a -1. And again, I have to look at the scale on the graph. In each one of these, each division is worth 1. So a -1, and then it says a -2. So this point right here is point A. Point B is 0, -5. I go nowhere on x, but a -5 on y. 1, 2, 3, 4, 5. And that's point B. Okay. Now we're going to get to the graphing, which is a whole lot harder for most students. So we're going to review the graphing. Okay, we're going to do problems 17, A and B. Okay. We're going to show you how to graph 2 different ways. So I'm going to show you in 17A how to graph using the x and the y intercepts, and then later in another problem how to graph using y equals mx plus b. Okay? So let's look at problem number 17. In order to do this graph, I have to do some work first. Okay? Before I go any further, I'm going to label my axes. This is x. This is y. Okay? And I'm going to put some numbers on my graph. You need to label and scale. Without a label and a scale, a graph is not complete. So I'm going to count 1, 2, 3, 4. 1, 2, 3, 4. By doing that, I know each one of my divisions is worth 1. Okay? I could have counted by 2s, could have counted by 10s, I could have counted by 1/2. I need to put enough numbers to know that every little, I call them tick marks, every little mark represents 1 unit. And now I want to graph the equation 2x minus 3y is equal to 6. Okay. In order to do this, again, there are many different ways of doing this. I find that when I have an equation in this form, if I find the x-intercept and find the y-intercept, it is usually the easiest way to graph. Now the x-intercept is where the graph crosses the x-axis. That's what the x-intercept means. Okay? That means you want to get an x number. To do that, you always make y 0, and you will get an x number to find the x-intercept. If you make y 0, that will give you an x number. So in my problem, I'm going to make y 0. So I'm going to go 2x minus 3 times 0 equals 6. And the reason I do that, that eliminates 0 times any number is 0. So this just gives me 2x is equal to 6. Divide both sides of my equation by 2, and I get x equals 3. So my x-intercept is 3, 0. It's a real easy arithmetic problem. That's how I find my x-intercept, where the graph crosses the x-axis. Then I want to find the y-intercept. And the y-intercept is where the graph crosses the y-axis. Okay? And when I want to do that, I want to get a y number, so I make x 0. So one time I'm going to put in 0 for y, gives me an x number, and I put in 0 for x, and I get a y number. So I'm going to take the same equation, 2x minus 3y equals 6, and this time I'm going to put in 0 for x. 2 times x, or 2 times 0 is 0, so it kind of eliminates it, and it makes it a real simple equation. I'm going to show the substitution, but if x is 0, I really just have a minus 3y left, but I'm going to show you that. And 2 times 0 is 0, so I get negative 3y equals 6. And now I have to divide both sides of my equation by a negative 3. And I get y is equal to, and 6 divided by negative 3 is negative 2. Positive divided by a negative is a negative. So I get a negative 2, 0. When I put in 0 for y, a 0, yes, 0 for x. Put in 0 for x, my y is a negative 2. That's my y-intercept. 0 for x, y is a negative 2. Be careful about how you write those coordinates. Go back and remember, I put in 0 for x. So now we're going to graph it. Okay? To graph this, I have my x-intercept and I have my y-intercept. I have the point 0, 3, 0 and 0, negative 2. Those are going to be my x and my y-intercepts. So I have 3, 0. That's x is 3, y is 0. 1, 2, 3. And 0, negative 2, 1, 2. And 2 points determine a line. So if I want to graph the line now, I just connect those 2 points. And I get my line. That's graphing with the x and the y intercepts method. Question? Okay. We're going to look at problem 12b, which is 4y equals 8. This problem is one of the easier graphing problems, but because sometimes easy problems become hard, this becomes very difficult for a lot of students. When I have, it's going to graph into a line, but I only have y's, I have no x's. So I want to solve for my variable. This says 4y equals 8. So I'm going to go 4y equal 8, divide both sides of my equation by 4, and I get y is equal to 2. Now I need to know what to do with it. Okay, first thing I want to do is label my axes. Remember, all axes must be labeled. And I want to scale it. 1, 2, 3, 4. 1, 2, 3, 4. So I know what each number is worth. And now the problem says y is equal to 2. Doesn't tell me about x, but it says y is equal to 2. 1, 2. That's where y is equal to 2. No matter what x is, y is equal to 2. This is what it means. No matter what x is, y is 2. So if x is 1, what's y? 2. If x is 10, what's y? 2. So no matter where I put my x, y is always 2. So what it ends up being is no matter what x is, y is 2. I just draw in my line. It is a horizontal line, y equals 2. And we call this a constant line. Constant. No matter what x is, y is constantly 2. It's a constant function. That's all there is to this graph. So you find the 2 on the y, and you know everywhere across that line, y is equal to 2. And that's all there is to it. Really simple. It's so simple that it becomes hard. Okay? Okay? Let's go to some more graphing problems. Yes?
Why did you put 4? Is only for C the difference?
What I did was scale instead of writing 1, 2, 3, 4, 5. I don't like to count them all because then it gets kind of messy. So if I just put a couple of points there, you know what each of them is worth. If I put an 8 there, you'd know each of them is worth 2. And that was just my scale. Okay? I have a very thick pen, and I can't write in all those numbers, or it gets so messy. Here's another graphing problem. And looking at this graphing problem, I think they're going to expect you to graph it a different way than the x and the y intercepts. You could graph it with the x and the y intercepts, but it's written in the form y equals mx plus b, or the slope-intercept form, so it's easier to graph it a second way. Okay? In y equals mx plus b, this is the slope-intercept form. You have it on your formula sheet. That formula sheet cannot be used during the final, but it's there with all the formulas in one place so that you want to study, you can look at that formula sheet. But you will not have it during the final. What this says is the number in front of x stands for the slope, and the number off to its side stands for b, which is the y-intercept. And remember on our last problem, the y-intercept is where the line crosses the y-axis. So if I'm looking at this equation, y equals 3x plus b, what I want to write is what is the value of m and what is the value of b. I actually want to write it so it makes the problem easier and I don't make a careless mistake. So the slope is the number, the numerical coefficient in front of the x. And in this case it is 3. And my slope in this case, that's 3. And my y-intercept, which is the b, is 4. Okay? That's all the information I need in order to graph this problem. So it has reduced the work. I first want to label my axes again. Always label axes and put in a scale. And the question was, I could write 1, 2, 3, 4, 5, 6, and so on. I want to write the scale, but I have a very thick pen. I could write 1, 2, 3, 4, 5, 6, -1, -2, -3, and so on. And the same thing up here, 1, 2, 3, 4, and that would be a -4. Just so that you know that each little square is worth 1 unit. You always start with the y-intercept first. That's where you start. This is where the line crosses the y-axis. In our earlier problem, that was when x was 0, y is 4. If x is 0 here, y is 4. 0 for x, y is 4. 1, 2, 3, 4. My graph starts at 4, at my y-intercept first. Okay? Now, slope is a rate of change. How much the y changes compared to the x. It's a constant rate of change. So, in this problem, when we're doing slope, slope is the change in y over the change in x. That's how I write the word change. It's a shortcut, delta y over delta x. How much does y change compared to how much x changes? That means that the slope is always a fraction. And in my case, the slope is 3, so I have to make it a fraction. And anytime I want to make a number a fraction, I can always write it as that number over 1. So my slope is 3 over 1. Now I have to do that because this says that every time my x changes 1, how much does my y change? 3. That's what it means. Whenever x changes 1, y changes 3. Or whenever y changes 3, x changes 1. But x is usually our independent variable, usually. So I usually do my x first and then my y. So from that point, it says go on x1 and go on y how much? 3. 1, 2, oh, I'm off my paper. So what do? Instead of 3 over 1, I can make this as -3 over -1, because that's the same number as 3 over 1. Negative divided by negative is 1. So I'm going to go a -1 from my y-intercept, and then I'm going to go a -1 on my y-intercept, from my y-intercept. I'm going to go a -1 on x, and then I'm going to go a -3 on y. 1, 2, 3. I can do it again. -1 on x, 1, 2, 3 on y. Pardon? Surely. And now I'm just going to connect my points. And this is the equation, the graph of the equation y equals 3x plus 4. Now, why did I do it this way instead of the x-intercept and the y-intercept? Because the original equation was in an easy form to graph by the slope and the y-intercept. So if I know more than one method, I'm going to try and use the easiest method. Question? Okay, let's look at part D. D is another simple problem that most of us have trouble with because it is so simple. Part D. It is an equation of a line. Okay, it's an equation of a line, but it's missing the y's. But I still want to get x by itself. So the problem says -2x equals 8. To solve for x, I divide both sides of my equation by a -2. And I get x is equal to -4. Okay? No x's and y's, just x equals a -4. Again, I'm going to write my axes in, x and y. And I want to scale 1, 2, 3, 4 on x, 1, 2, 3, 4 on y. All those numbers are to let you know that I have each unit one of those division lines. And I have to find a -4 on x. -1, -2, -3, -4. but this is a line. This says, I don't care what y is, x is a negative 4. Y can be anything. In this case, it's a negative 4, 0. In this case, it's a negative 4, negative 2. In this case, it's a negative 4, 3. I don't care what y is, x must stay a negative 4. So anywhere x is a negative 4 is going to fit that equation. Y's can be anything. And then I'm going to connect those points. And this is the equation of x equals a negative 4. This doesn't happen to be a function, but it is an equation of a vertical line. Okay? So you just say, oh, x is a negative 4. What does it make sense for? All of the x's are a negative 4. That's all there is to it. Okay? Let's go to problem number 18. 18 is not too difficult. Okay. This says identify the x and the y intercepts of the following graphs or equations. X-intercepts where the line crosses what? X-intercept, line crosses the which axis? X-axis. Y-intercept where the line crosses the y-axis. Okay, so I have this point and that point. This point is this line is crossing the, which axis is this? X-axis, so the coordinates of that point. Notice in this problem I only have numbers every 5 because it's too messy to write them. So every one of those divisions is worth 1 because I have those numbers there. So this line crosses my equation, my axis, my x-axis at 1. So the x-axis, the x-intercept is 1, 0, right here. And this is going to be where the line crosses the y-axis, which is your y-intercept. And the y-intercept is 0, negative 5. Question? Okay, we're going to problem 19. Okay. If you look at number 19, it says solve the system of equations. A system of equations means more than 2 equations graphed together to find a common solution. So in the A part, it says I have a graph of a line here. Okay? Where do the 2 lines? I have a graph of 2 lines. This is one line and this is the second line. And where do the 2 lines meet? When it says solve the system of equations, it means is there a common solution to both equations? And in this case, it's right here where A is, point A. So the solution is an x, y solution. What is the common x and y point for both lines? So I go over and read, and it is 3, 6. So the solution to the set of equations, to the system of equations, is 3, 6. That is the only point that's common to this line and this line, my 2 lines. Okay? If you're graphing, that's fairly easy. But if you look at problem D, what problem D says, I have 2 equations. They're both with x and y. They both graph into lines, but I don't want to graph them because that's not accurate enough. I want to solve them algebraically. So there's more than one way of solving a system of equations algebraically. You have to look at the problem and say, what does it look like is going to be the easiest? And in this method, the substitution method looks like it will be easier. The first equation says y is equal to 2x minus 7. And then the second equation says 2x minus y equal 3. Well, I know what y is worth. It's telling me, it being the system of equations, says that y is worth 2x minus 7. The word substitution means anywhere I see a y, if I want to, I can put 2x minus 7 because they're worth the same thing. So I'm going to take this first equation and put it in or substitute it into the second equation. So I have 2x minus, and now it says y. Well, I don't want a y anymore. I want to write what y is worth. And what is y worth? 2x minus 7. But I must put it into parentheses, and I know that's worth 3. Okay. And now I have an equation to solve for x. All I have are x's. What I've done is I've eliminated one of the two variables. Okay, if I have two variables, I need two equations. If I have three variables, I'll need three equations. If I have four variables, I'll need four equations to find a common point if it exists. Well, I have a minus and a parenthesis, so I've got to distribute my subtract sign or my negative sign over the entire parentheses. Do not try to skip steps or you will make careless mistakes, or you have a tendency to. So I'm going to have 2x minus 2x plus 7 is equal to 3. Right? 2x minus 2x is 0. I get 7 equals 3. Oh my gosh, my variables disappeared. Did I come up with a true or a false statement? False. This is false. If I come up with a false statement, it means there are no solutions. And when there are no solutions and you're working in one plane, what generally means is my two lines are parallel and they will never intersect. The slopes of the two lines are the same. They will never intersect. If I come up with a true statement, that means that any solution of the first equation is a solution of the second equation, and I would have infinite solutions. But here I have no solutions. And this is where we're going to choose to stop. We haven't finished, but you have been great. It is now 12 o'clock. What we're going to do is on your way out, you are going to get another practice final exam with solutions at the back. So you have another set of final exams to practice with and solutions so that you can do some more work. Remember, the math lab is open from 8 in the morning until 8 in the evening so that you can go up there before your final exam. Y'all have been great.